Hello everybody, and welcome to the fourth and final session of this IEA Online Statistics Summer School. There will be a presentation followed by an interactive question of your screen. Please don't hesitate throughout the presentation and the session. Ask the questions. There will be a moment that we ask you to ask questions particularly, but if there's anything on any particular slide during this time, don't hesitate and we will answer. Klaus has just put up a quick poll to ask if you can hear as well, if there's any problem. Yes or no. And I see that apparently it's quite successful, and there's a few people who are answering no. Normally that's not a technical issue, that may be something with your computer on your side, so I think we'll go with the majority.
Really a key essential application of all the efforts made in collecting. I hope I can. So many of you know, especially those that attended previous lectures, that there is, for example, natural gas or in some different sources, and they give us a lot of information already. But in fact, it's only when we put everything together our house that we understand the relationships between different blocks, and we actually the that the on-nation organizations went to this product, of course the IEA as well. But we go back to our very important topics, energy balances, to understand why we make so much effort to develop energy balances for countries, for regions, even for the world actually. I said, to get the overall picture of an energy situation in a country, in particular, for example, you want to know maybe very simply how much energy a country is using in a year, or compared to last year or compared to other countries. So this would need a set of steps to make. You want to understand overall the importance of different sectors in energy demand. Is it a country with a lot of industrial, say, intensive sectors, or is more services oriented? Do we consume a lot of energy in households? What type of energy sources are actually important in the mix? Is it more renewables, more fossil fuels? All this type of information you can understand from the overall picture of the energy balance. Further, you can develop indicators and emissions estimates Many of you may be familiar with the process international of the Sustainable Development Goals. So there has been a number of targets for each goal. The energy has 3 targets itself, a specific goal, and these indicators are also linked to the information of an energy. Similarly, for model, the balance tool to assess looking at the interrelationship between more about what is missing, what is maybe. The first part of this talk will guide you through like what type of information we can recover from it. Knowing that there is a huge impact in the couple of examples of applications of energy balance. How does the balance matrix see here? It's an example for one individual country. The level of so this is just one example. So what we see here, each individual column is representing what we call a commodity balance for a given product or product category. In this case, it's coal. So by commodity balance, I mean all the description of what happens to coal from top to bottom, from production to trade to supply, and then where coal is used, for example, for electricity or in the industrial sector. So this is what I mentioned initially when we collect the data from different sources around different fuels. But then we, by developing an energy balance, we are actually introducing the second dimension here, this horizontal reading of the matrix, and this is the key added value here. It's because with the rows, we are representing the flows of energy across different products, all the relationships. For example, in this example, I highlighted the refineries, because in a refinery, you have a transformation between a primary product, like crude oil, and its secondary products, which are oil products, you know, for example, gasoline, diesel, etc. And the secondary products, in this case, are made available for final delivery to users, which the crude oil is not so good for. So you see this idea of a relationship between different products that is added by the fact that you are developing the balance. The first key point to understand then, as we collect the data in different sources, in different units, for example, cubic meter for natural gas, or actually to compare all the different data, the data on the basis of energy. Content. This is then we can feel of having developed. And so as you know, if you have followed other up activity quiz here, it's simple, but just to make us think a little, not attended lectures. So what do I need in terms of data? To specific gravities? What do you think? It's good. It's what we expect. The result of the probably very simple to understand. It's important to think if values vary, quality of the individual product, and for example, these values. So in itself, the calorific values are representing a very important challenge in terms of data collection. But we need to be aware that the data quality of the final energy balance will depend strongly also on the information we have on calorific values. So we talk about the common energy unit, but now we go really in depth into the understanding of our balance. We mentioned this idea of first supply, which is the top part, the trans-consumption block. What the very basic level. First, energy supply. This is the top part of the matrix. I call it the quick overview. This is a very set of numbers, if you think about it. Not a lot. Maybe statistics, but the information is very meaningful there already. Because, for example, is there that the country is producing and the exporters or producers, etc. If there is one number you need, which is this number here in red, because this is first approximation of all the energy in a given year, for example, and how big it is. For example, I don't know, France to 104, even have to other countries. How does it compare to last year? This part is what we call transfer, how different products are transformed into one another. As I mentioned, because the final users prefer certain type of sources compared to others, and so we need transformation. So there we have a number of transformations. One that I'm highlighting here is the electricity. The large quantity of considered as input. So it's burned by the which. So in terms of an energy balance, we assume the convention that the minus of energy, how much electricity is coming out of this transformation. Even talk about which is the ratio between output and input, and it's a very important. So in this transformation part of the matrix, we recover what type of product, how efficiently, and also additionally how much energy this process is required. Because, for example, to run operations. And here is where also so 100 units of, and can share this. You can share. We see that there is a group of optimists. It's very, many of you actually know this. And not this sense that the average. This is, as I said, an value, and coal is the largest source used for electricity during the generation of electricity. It's remarkable if you think about that. There are ranges. For participating, what we call final consumption and drivers, because finally, because you need energy to move your car, your goods, and that's what we call transport, etc. So household passengers. The question, who is using what, basically? So what is driving? Important to understand the structures, to understand how to manage the users, that you have a lot of different users. For example, and this is an effort. That's also where maybe the countries vary. If you look, not everybody at the same level of detail available. In the data collection. I have another question, but it's the last one. And knowing that you have very, very varied situations. Fluidity is growth. So we see a diagram chart, and so you see that the majority once again understood that industry is still the leading sector for energy consumption, but the transport is quite a lot close to that, and so the second group also was right in that respect. In fact, if you look at trends in time, actually a smaller share into this. So residential as well is very important, still the largest. So encouraging everybody to understand the situation, how the structure in terms of energy consumption is, because this is an another very important information we get. So we had a very quick question.
There's in the previous slide, how is wind energy considered as a renewable energy, or?
Right, wind is a renewable energy. They need to go back. It's in this case as a total, because the final consumption of electricity from the grid, you don't really where it comes from. Final, so you can recover from the other parts of the matrix where this electricity comes from, and in fact the transformation part of the matrix is useful for that. The different sources going into the final electricity product.
Yep. Yep.
So we move. Do we move?
There's also another question here, that maybe if you have time to take this one.
Yes.
How is this taken care of over time? Can components in each block change over time? Do you sometimes have new supply sources, new transformation processes?
Right. That's right. To the same exact period, and there were some statistical difference actually come visit.
Fine.
Some countries do produce balances in terms of coal equivalent, for example, China, I think, and this is because they are interested more into that. But we just converted to other energy units rather simple. Well, I'm glad at this point gives a lot of information. I'm proposing actually now and also hidden, it's transposed in fact, because here you see all the products in the different rows. So you have coal and with the same gas here. And then the three blocks are here like from left to right. So the supply part is here, the transformation is here for us, and then the final sectors are here. This is the country, Mexico. You can play on our website with those. We have all countries available, and also variation in time for this, which shows the response to the question before. Things change in time. You can have movement in this matrix. But I think it's very convincing, because here I see right away, without knowing Mexico, that I have a huge, very significant oil production, out of which a significant part is going to export. So it's an oil exporter. then what I see, there is a large infrastructural refining in this country. And I also see that power generation is made by gas. I already have a lot of knowledge, but also I see that in the end-use sector, transport is quite important. It's actually much larger in this case than in the global average we have seen earlier. So in 3 seconds or 4, I have identified maybe the 4 or 5 key features of the energy picture in a country, and this is thanks to our energy balances. I have a couple of additional slides to show the benefits of building energy balances, because we have a lot of users. Maybe some of you are users of our data, hopefully, and our first users are in fact inside the agency. Maybe you are familiar with the World Energy Outlook. This is a slide taken from this publication. So modeling projections into the future. It looks like a very simple slide, but you think about that, projecting demand across different countries requires so much knowledge of the energy balances of each individual country, how they evolved in time, what the energy mix is, what demand sectors are, etc. So a lot of data collection globally needs to be done, and thanks to maybe you who are working in energy statistics, World Energy Outlook can be published. A second example, I briefly mentioned at the beginning, the high-level indicators. This is taken from our website. So I'm showing here energy per capita, TPS per capita, by country, for example. So we couple the data in the energy balance with other socioeconomic data, and we develop indicators. Indicators are very important. As I mentioned, the SDG, for example, have now defined the energy intensity, one of the most important indicators to monitor in the future. Reduce energy intensity, we mean reduce the energy use per unit of economic output, GDP. So this is another, for example of uses of energy balances. And then similarly, emissions from fuel combustion, because you are probably much aware of the climate change discussion, the UNFCCC, COP work, etc. So emission energy is definitely at the core of climate change because of anthropogenic drive mainly from energy through the CO2 from fuel combustion. In this case, once again, we have a methodology of energy balances coupled with the methodology provided by the IPCC, which is the Intergovernmental Council for Climate Change, which tells us exactly to estimate gas by gas. So it's another use of power from energy. I think I'll be honest if I said that the energy balance, that's it. That's the only thing you need, because now that you know it's very powerful, maybe you have appetite to get even more information. That's where we are trying to move in the future. Just a little flavor for that. This shows actually the disaggregation for the countries which we have actually data for of the total that is shown in a balance for residential energy use, the pie on the right, so OECD countries, how the actually various end uses are driving this residential consumption. This is very interesting for energy efficiency monitoring. And we see that in this group of countries, for example, space heating is very, very important. But also appliances are growing, and you see different trends across different end uses. And this is where we want to go in the future. So if you're working on energy statistics, I really hope that you can also move at your national level towards this level of disaggregation. And it's also an idea for a further webinar for Lucy. So the overview was complete here. I don't know if you have further questions.
There's a question that's just come in about asking how we treat bunkers, domestic and international, within the energy balance.
Oh, that's underline energy data. We are excluding the we have various, a few percent, the collection is the other 5, 10%
countries?
Ideally, you have good information. It depends on the,
what is
the country. It's certainly less accurate for non-OECD countries in our data. Why? Because the IEA members have more commitment to us to provide accurate data, especially on energy security. So stock, for us, it's really one of the key reasons why the IEA data existed at the beginning. So certainly then the accuracy is higher for OECD countries than for the others. We also collect stock levels for OECD countries and not for non-OECD countries. We have only the change in stocks in the same year.
There's a question here. Do you have some general recommendations on how to get valid end-use data on the final consumption?
We have another webinar this one. Because, as I said, the final consumption data are the most difficult. We have a number of different methodologies adopted by countries. The first easiest is the administrative sources. So look if someone else is collecting similar data for other purposes, maybe taxation, for example, and then you can use the same data with little marginal cost. Then you can use a specific ad hoc designed surveys, and then it's a little bit more of an effort, but it's also maybe giving you what you really need because you are targeting these questions ad hoc. You need a good sample, so you need a good investment there. You can have some metering, and metering is maybe very costly because you have only to certain type of equipment, you need installation, so it's a limited sample, but it gives you very accurate information, maybe for validation of broader survey results. And then you have some modeling techniques, and also there you go into the domain of assumption, methodology, input to data quality. In general, countries are adopting a mix of these techniques, and we have some reference documentation. For example, in our database for country practices in the website of the IEA, we have examples of what countries are doing across the different sectors to collect their data, for example. I think you can send the reference also some of this discussion on data collection methodologies.
What is the acceptable percentage of losses in electricity generation?
This is not a data question. It's a question on what you can accept in the process. The losses vary a lot depending on the technology and on the efficiency of the process, of course. So you can have, I don't know, for some combined cycle gas turbines, something around 60% even at the plant, but then the average is different. So you need to know your technology and what to expect and in what operational conditions you are running the plant, because if it is not optimal, then you're lowering the efficiency. So it depends a lot on what the plant is, what the technology is used, and the quality of the product.
Okay, there's some questions that have come up. If you've not answered it, we will answer it by email. And I would like to thank Roberta for a fantastic presentation today. Thank you all for joining us. That does bring us to the end of this 4-week summer school. And thank you all for participating. As advertised, those who have taken part in all 4 sessions will receive a certificate from our Chief Statistician for completion of the program, and that will be coming to you over within the next couple of weeks. We will be circulating a small evaluation on the webinars. If you can find a few minutes to fill this in, it's really useful for us in taking forward our ideas for online training and for creating new series such as this one, which I hope you've all found useful. So please do try and just find the time for that. That will be coming to you before the end of this week. You will be added to a database now and updated on all our upcoming online training, and so we'll keep you informed. As Roberta mentioned, please do visit the website. I mentioned at the end of the on the slide here. There's lots of more useful information and further developments and things you may have learned over the last 4 weeks. Don't hesitate to stay in touch with us. My email is still on the site. All 4 things and all 4 presentations will be made available on the website. 2 of them are already there, and the other 2 will be made available very shortly.
What is the address of the website?
It is, if you on the IEA website,